Hi again, this is Sir Art, your teacher for this second video tutorial. Our topic is about evaluating functions, the content of the second module of Quarter 1 in the Senior High School General Mathematics. In this video, you will be able to learn how to evaluate functions. So let's start. In the function notation y is equal to f of x, it tells you that y is a function of x. So if there's a rule relating to y to x, such as y is equal to 2x minus 1, then you can also write f of x is equal to 2x minus 1, wherein f is the name of the function, but other letters may be used to name this function, especially g and h. So x is the input, then 2x minus 1 will be the output. So here, quantity x is read as f of x. And this represents the value of the function at x. So function notation gives you more flexibility because you don't have to use y for every equation. Instead, you could use f of x, g of x, or h of x. And this makes you easier in evaluating a function if you have different values of x. So to evaluate function, take the given value of x and replace or substitute that value for x in the expression. You can simply apply what you already know about evaluating expressions to evaluate a function, like in the following examples. Example number 1, evaluate the function f of x is equal to 2x plus 4 at x is equal to 3. So the solution, just replace the variable x with 3. So copy the function f of x is equal to 2x plus 4, then replace x with 3. That becomes f of 3 equals 2 times the quantity of 3 plus 4. Then simplify. So 2 times 3 is equal to 6 plus 4. So 6 plus 4 will be 10. Therefore, the answer f of 3 is equal to 10. So that is the answer in example number 1. So let's proceed to some uh, reminders. So remember that f of x or f quantity x means the value of f at x. It does not mean f times x. Letter B, letters other than f, such as capital G and capital H, or small letter g and small letter h, can also be used. Then letter C, f is the name of the function, and f of x is the value of the function at x. So those are reminders for you to remember. Example number 2. Evaluate the following functions at x equals 2.5. Letter A, f of x is equal to 2x plus 1. Letter B, q of x is equal to x squared minus 2x plus 2. C, g of x is equal to the square root of x minus 1.5. And D, r of x is equal to 2x plus 1 over x minus 1. Then letter E, f of x is equal to the floor function of x plus 1. Letter F, h of x is equal to 25 times the ceiling function of x minus 2. So let us answer those items. So letter A, f of x is equal to 2x plus 1. We're going to evaluate this function at x is equal to 2.5. So just simply substitute x with 2.5. That is f of 2.5 is equal to 2 times the quantity of 2.5 plus 1. Then we're going to simplify. 2.5 times 2 is equal to 5 plus 1. Then just add 5 plus 1. So the answer is f of 2.5 is equal to 6. So let's proceed with letter B. So letter B, q of x is equal to x squared minus 2x plus 2. Same step, we're just going to substitute the value of x, which is 2.5. So it becomes q of 2.5 is equal to 2.5 quantity squared minus 2 times 2.5 plus 2. So after that, we're just going to simplify. The square of 2.5 is just 6.25. 2 times 2.5 is 5. Then copy 2. So that becomes 6.25 minus 5 plus 2. So we're going to simplify. 6.25 minus 5 is just 1.25. Then plus 2, that is equal to 3.25. So the answer for letter B, q of 2.5 is just equal to 3.25. So let's proceed to letter C. C is g of x is equal to the square root of x minus 1.5. Substitute the value of x. So g of 2.5 is equal to the square root of 2.5 minus 1.5. So it becomes 1 because 2.5 minus 1.5 is just 1. So g of 2.5 is equal to the square root of 1. Then the square root of 1 is just equal to 1. Therefore, the answer in letter C, g of 2.5 is just equal to 1. Then for letter D, r of x is equal to 2x plus 1 over x minus 1. So substitute the value of x with 2.5. That becomes r of 2.5 equals 2 times 2.5 plus 1 over 2.5 minus 1. So 2 times 2.5 is equal to 5 plus 1. 2.5 minus 1 is just 1.5. So 5 plus 1 equals to 6 over 1.5. So we're just going to divide 6 by 1.5. So therefore, r of 2.5 is equal to 4. So that is the answer for letter D. So let's proceed to letter E. Letter E, f of x is equal to the floor function of x plus 1. So in this problem, let us note that the floor function of x is a floor function applied to x. So the same process, we're just going to replace x with 2.5. So equals to the floor function of 2.5 plus 1. So to get the floor function, round down 2.5, which is 2. So we're just going to get the floor function because the floor function gives the largest integer that is less than or equal to x. So it becomes f of 2.5 is just equal to 2 plus 1, since the floor function of 2.5 is just 2. So 2 plus 1 is just equal to 3. So f of 2.5 is equal to 3. So that is the answer for letter E. So let's proceed with letter F. H of x is equal to 25 times the ceiling function of x minus 2. So note that the ceiling function x minus 2 is the ceiling function applied to x minus 2. So the same, just replace x with 2.5. That is equal to 25 times the ceiling function of 2.5 minus 2. Okay, so 2.5 minus 2 is just 0.5. So it becomes h of 2.5 equals to 25 times the ceiling function of 0.5. So to get the ceiling function, round up 0.5. So a while ago, we get the floor function, we round down. Here, we're going to get the ceiling function, we're going to round up. So round up 0.5, which is 1. Because the ceiling function gives the smallest integer that is greater than or equal to x. Therefore, just get the ceiling function of 0.5. It becomes h of 2.5 is equal to 25 times 1. So therefore, 25 times 1 is just 25. So h of 2.5 is equal to 25. So that's it for letter F. So let's proceed to the last example. To that. Okay, given g of x is equal to the square root of x minus 1 and r of x is equal to 2x plus 1 over x minus 1. Find g of negative 4 and r of 1. So solution, we're going first to answer g of x equals to the square root of x minus 1. We're going to evaluate that at x equals negative 4. So simply replace x with negative 4. It becomes g of negative 4 equals to the square root of negative 4 minus 1. So negative 4 minus 1, it becomes g of negative 4 equals square root of negative 5. So here, we had a negative radicand. So we're in, it is not possible because negative 4 is not in the domain of g of x. Okay, since the radicand must be non-negative. But if the index is even number, but it can be negative if the index is an odd number. So for r of x is equal to 2x plus 1 over x minus 1, we will just simply substitute x by 1. So r of 1 equals 2 times 1 plus 1 over 1 minus 1. So 2 times 1 is 2 plus 1 is 3. 1 minus 1 is 0. So 0 becomes the denominator. Therefore, it gives you undefined number. So 1 is not in the domain of r of x because we'll make the value of the denominator equal to 0. Note that if the value of x is not in the domain of f of x, then f of x is not defined at x. So that is for example 3. So let's proceed with example 4. If f of x is equal to x squared plus 5, if x is less than 0 and 5x minus 1 if x is greater than or equal to 0. We need to find a f of negative 2 and letter b f of 4. So for letter A, to find f of negative 2, we will let x equals negative 2. So since negative 2 is less than 0, we're going to use the first line of the equation, which is x squared plus 5. Because it states that we're going to use this one if x is less than 0. So since negative 2 is less than 0, that's why we're going to use the first line of the equation. So f of x is equal to x squared plus 5. Substitute x by 2.5, by negative 2. So it becomes f of negative 2 equals to negative 2 squared plus 5. So negative 2 squared is 4, then plus 5. So f of negative 2 is equal to 9. So that is the answer for letter A. So let's proceed to letter B. To find f of 4, we're going to let x equals to 4. Since 4 is greater than 0, we're going to use the second line of the equation, which is 5x minus 1. Since it states that if x is greater than or negative 1, we're going to use this sub function. So the same, just copy the sub function. F of x is equal to 5x minus 1. Substitute 4 in the variable x. It becomes f of 4 equals to 5 times 4 minus 1. So 5 times 4 is 20 minus 1. Therefore, the answer is 19, since 20 minus 1 is 19. So that is the answer for letter B in number example 4. So in example 5, let f of x is equal to negative x squared plus 5x minus 3. And g of x is equal to 2x plus 3. Find each of the following. Letter A, f of 2b. Then letter B, g of a plus 1. So notice that we're going to evaluate x by not just a number, but an expression. So the same process, we're just going to replace x with 2b. So f of x equals negative x squared plus 5x minus 3. Replace x with 2b. It becomes negative times 2b squared plus 5 times the quantity of 2b minus 3. So simplify. 2b squared is 4b squared. Since there's a negative outside, it becomes negative 4b squared plus 5 times 2b is 10b minus 3. Since there are no like terms, therefore that will be our final answer. So letter B, we're just going to replace x with a plus 1. So g of x equals to x plus 3. Replace x by a plus 1. It becomes g of a plus 1 equals to 2 times the quantity of a plus 1 plus 3. So let us distribute 2 in the parentheses. That becomes 2 times a is 2a. 2 times 1 is 2. So it becomes g of a plus 1 equals 2a plus 2 plus 3. So you can combine 2 and 3. Therefore, the final answer is g of a plus 1 is equal to 2a plus 5. So that's it for the second module. Again, thank you. This is Sir Arthur Lawrence Yee. So again, let us see each other in the next video tutorial.